All right, I want to do another interval of convergence problem here. You'll see the equation we have here in this particular case, or the series we have, I suppose, is x minus 3 to the n over n. So again, you might need to write a few terms out. Sometimes they ask you to write a few terms. By the way, a piece of terminology I haven't used yet. If they ask you for a third-degree Taylor polynomial, or a fourth-degree Taylor polynomial, what they're saying is write out the number of terms to that power. So here you can see if I just stopped it, this would be a third-degree polynomial. Of course, it's actually going to continue. But basically, you've got n to the first power over 1, that would be your first term, n to the second power over 2, and so on, and those are your terms. Make sure you keep in mind n generates the individual terms. You're going to have a variable in these because these are representing some kind of functions. Okay, so remember the idea here is you're applying the ratio test, and we really need the limit as n approaches infinity of the n plus 1 term divided by the nth term. We need that ratio to be less than 1. Okay, and then actually, if it's equal to 1, we need to check and see if it works or not. It's actually inconclusive. So we can just substitute in here. Remember, you're substituting in for n, not for x. Okay, you got to be careful. It's very easy to do that, especially when you're first doing this. So anyway, I'm going to start off here. I'm just going to go ahead and substitute in here. Save a little space on the board. So we're going to do the n plus 1 term. That would be x minus 3 to the n plus 1 power, okay, over n plus 1. And then we're dividing by the nth term. So these are usually going to be ugly. You're usually going to have a fraction over another fraction. The nth term, of course, is just the original one that I was given, okay? Again, so we want to simplify this thing down. Don't lose the limit. We haven't taken the limit yet. It's still the limit as n approaches infinity. I would probably write it as multiplying by a reciprocal, okay? So you've got x minus 3 to the n plus 1 power over n plus 1. You're going to multiply by the reciprocal. That's going to be an n on top. You're going to get an x minus 3 to the n on the bottom. And hopefully you're going to see a lot of things that potentially can cancel and simplify. Okay, so I'm going to rewrite this and kind of group things a little bit. That's always helped me at least. I'm going to group the x's together, x minus 3 to the n plus 1 on top. We have an x minus 3 to the regular n on the bottom. We have an n and we have an n plus 1. Okay, and if you take a look at this, first of all, everything here is being multiplied just like this. These are equivalent. You can't break it up as two separate fractions. It's really this times this. So we're going to get the limit as n approaches infinity of, and if you look at it, n of these are going to cancel n of these. That's going to leave us with just a single x minus 3, okay? And then it's being multiplied by n over n plus 1. Okay, now you can apply the limit. I've simplified all I can, okay? I can't divide an n out of the top and the bottom there because of the addition, okay? Now we can apply the limit, okay? Notice, as n grows very large, they're going to overpower that 1 there. So we've got a first-degree term, the numerator and denominator. That whole thing is just going to approach 1 as n approaches infinity. So that doesn't always happen. I guess if it was a 2n over n plus 1, it would approach 2, for example. But you'll see that kind of thing happen pretty often. Okay, so this whole expression is just going to simplify down to be the absolute value of x minus 3. We need that to work out to be less than 1. Okay, so to come back here and look at what we've got now, what we've really got now is just 1 times x minus 3. So the absolute value of x minus 3 needs to be less than 1 to make this convergent, okay? Well, what does that tell me? Well, if the absolute value is less than 1, that means x minus 3 has to be between 1 and negative 1. So I would usually take it out of absolute value form so I can evaluate it. And we've got a little inequality here. I want to know what values x is between. So I can add 3 here, I can add 3 here, I can add 3 here. We're going to find out that x is between 4 and 2, okay? This is the interval of convergence, okay? I technically need to check the endpoints, which is another issue. By the way, 1 would be halfway between let's see, 2, 3, 4. Sorry, 3 would be halfway between 2 and 4. By the way, you should be able to see that this was centered at 3, just from our work with generating Taylor series. So this would be centered at 3, and it basically says you could go up 1 from 3, and you could go back 1 from 3. We would say the radius of convergence is 1, just that we can go 1 up and we can go 1 back from the center. And this is the interval of convergence. Okay, now the follow-up. To finish this out, technically we need to check the endpoints, okay? And again, I don't think this is going to show up on the AP exam this year, but if you took a Calc 2 class, they would certainly have you check the endpoints. And sometimes you can substitute back into the series. Sometimes you might just want to substitute into the individual term. But remember, these are x values. So we're checking x equals 4, okay? Now if I put 4 in here, I get 4 minus 3 is 1, okay? If I put 4 in here, 4 minus 3 is 1, squared is a half. 4 minus 3 is 1 over 3, okay? I think you're going to get 1 to the 4th over 4. And if you notice, that's the harmonic, okay? The harmonic diverges, okay? So if x is equal to 4, this is a divergent series. I'm not going to put an equal sign in there, okay? Now, let me go back in and put in x equals 2, and let's see what happens there. A lot of times you're going to get series that are linked, but maybe with slight differences. 2 minus 3 is negative 1. 2 minus 3 is negative 1. Squared is positive 1 over 2. 2 minus 3 is negative 1 cubed is negative 1 over 3. I think you're going to get a plus 1/4 and so on. If you notice, that's an alternating harmonic, which does converge, which means x is allowed to be 2 and you get a convergent series. So that's the overall interval of convergence, okay? We could also say, we could write it using interval notation. We could do 2 to 4 and have the curved parentheses for the less than and the square brackets for the equals, okay? But that's the idea. Oh, by the way, one other thing. Some of you may prefer to substitute into the original statement with your 2 and your 4 as well. So just to show you that alternate approach, if you put in a 4 here, you would get 4 minus 3 to the n over n. Well, that's going to simplify down to 1 to the n, which is always going to be 1, right? That's the harmonic, or you could say it's a p series with p equal to 1, which diverges. So that tells you that x equals 4 would not work. For x equals 2, you would get 2 minus 1. You would get negative 1 to the n over n. And hopefully you would recognize that's the same thing as negative 1 to the n times 1 over n. That's an alternating harmonic. And again, according to the alternating series test, the terms will approach 0 and it's alternating, so it will converge. So again, you can check it with the general term, or you can just write out terms of the series and look and see if you recognize it. And sometimes one approach will work better than the other. It just kind of depends. But anyway, hope that's a helpful example of how the test for convergence works using the ratio test.